It's a pleasure to be in this great space and a pleasure to be part of that family that is IIASA. I'm a water practitioner and policy wonk, have been for most of the last 30 years, spent a lot of that living in Africa and Asia, and have become a scientist again quite late in my career. And I'm reminded that science without policy is science, but policy without science is gambling. And in an awful lot of the places where I work, there is policy without science. I'm going to talk about water and boundaries and try and make 3 points as quickly as I can, given the time. First of all, water security we define as tolerable water-related risk to society, and that's at all levels, from the individual, the family, the farm, to the planet. Water is typically argued as being a local problem, and it has been for centuries, for millennia. Only in the last couple of centuries has water moved beyond the human settlement to the hinterland, to the nation, to the basin, and only in the last century to basins that move beyond national boundaries. I want to emphasize one thing. There's a massive, from my experience, a massive north-south divide. First of all, we have an extremely good correlation between hydrological complexity, by which I mean variability of rainfall and runoff, and unpredictability of rainfall and runoff. There's a correlation between that and poverty and economic growth. And that is an inverse correlation between complexity and growth. So we see in the South a massive, massive problem that was never faced by most northern countries in their path to growth that could do with water very quickly. And when we look at African rainfall, it's 700 millimeters, by the way. It's 700 millimeters in Europe. So what's the problem? The problem is variability and unpredictability. We only have 10% of the monitoring stations in Africa that we have in Europe. So here we don't need as many, but we have 10 times more. You cannot manage what you do not measure. But the cost of measurement, the complexity of measurement, the skills required are very considerable. So a massive information shortfall. Now, beyond the nation state, water security in international transboundary waters, we've got 260 international rivers, nearly half of the world's land surface, and 90% of all nations sharing rivers. Take a continent like Africa, you've got 60 international rivers. You've got Guinea upstream on 13, Mozambique downstream on 9. It's really difficult to manage one with a neighbor, let alone 13. And these are lines drawn on maps in London and Paris and Lisbon and Berlin and Rome that took no account of culture, of geography, of hydrology. The border between France and Spain is more or less the watershed. And it's the watershed for a good reason. I mean, that was the stable place to draw an international boundary. Is water local? We have a fundamental principle in the law of nations, and that is one of sovereignty. And there's a fundamental underlying point with the management of water around sovereignty, which means secrecy of water data. Many countries, we mentioned India earlier on, data from the Ganges Basin is largely secret, including topographic data. And I'll come back to that in a moment. China, upstream on 110 rivers and lakes, share with 18 neighboring countries a total of 3.5 billion people in those countries, half of the world's population, and almost no science, no scientific cooperation, no institutions. The lack of knowledge, the absence of knowledge creates massive misperceptions. Misperceptions create fears. Fears create unstable international relations. Science can prove that this is entirely wrong, that if we begin to understand and unpack, we will be able to see international rivers in a very different light. For example, upstream in the Nile, you can take more or less as much water out of the Nile as you can use for irrigation in East Africa, and Egypt will not see the difference. The presumption has always been that if East Africa touches the waters of the Nile, Egypt will be destroyed. On the Ganges, there's been an assumption that dams in Nepal are essential to prevent floods in Bihar and UP and West Bengal. That's not true. You cannot store enough water in whatever dams you might build in Nepal to prevent floods in the Ganges floodplain in India. So the imperative of science, science that is able to demonstrate that the risks and the opportunities can be managed, and that the benefits, essentially cooperation on international waters, cooperation on all rivers, is a positive sum game, almost invariably. My third and final point is that we're heading in a direction of a paradigm shift, an essential paradigm shift in water management, where our policy boundaries must progress from the local level to the planetary level. We live on one blue planet. Adil said earlier on, if you look at this planet from space, he told us what you would see, but you will see the only blue planet in our solar system. And as far as we know it, the only blue planet in our universe. And it's blue because of water, and we're here because of water. Only 1% of the water that we have is fresh and liquid, and that's worth bearing in mind. But we have almost no understanding of global fluxes of water. We do not understand water beyond the nation state. We basically do not understand that flux. But when we look today in a rapidly changing world, changing economies, changing demography, changing political systems, and of course climate change, and can I come back to the fact, by the way, that maladapted people, half of the world's people are maladapted today. Climate change is not the issue they face now. They must adapt to the problem they face today in order to be able to adapt to tomorrow. So the adaptation deficit is massive. Just a word about a couple of spillovers. 2010, drought in Russia, grain export banned in August, price spiking immediately, price increases of food in the Middle East up by, well, doubling essentially by that winter. Paul Krugman writing specifically about weather and agricultural production leading to food price spikes that caused public rage that triggered the revolutions that we saw in North Africa that winter. The Thai floods last year, 2011, the fifth most costly disaster that we have on record at $45 billion, $15 billion of insurance loss, Lloyd's of London declaring a major loss of $2.5 billion. These spillovers becoming increasingly frequent. The Japanese GDP suffering because of the Thai floods, computer prices spiking worldwide, Honda production in the United States down 50% last winter as a consequence of breaks in the supply chain of car parts. Toyota down 260,000 vehicles, declaring a massive reduction in profits that year. Now let me bring this to a close. For the first time in human history, water knowledge is a global public good. It's non-excludable, it's non-rival. We've got a combination of satellite systems, computing power, the ability to handle large amounts of data. We have communication systems, we have social networks, we have citizen engagement that means that we can manage water across the planet. It is unacceptable that 75 million people living in the Ganges Basin in 2007 were severely affected by floods without early warning. 75,000 square kilometers of cropland destroyed in that same monsoon flooding episode. No information, lack of information. We can get to everybody on the planet everywhere through mobile phones with real-time data. Crowdsourcing can improve that data. We can do things today that we've never been able to do in the past, and we must learn to do it. So sovereignty, stationarity, and secrecy essentially are dead. Our one blue planet requires a manifesto of understanding, knowledge, and management from the local level to the planetary level. Thank you.